Assalamualaikum. My name is Quratul Aina binti Zulkarnain. Nombor matric card B0920104436. Now I will present about the application of second order system for the washing machine. First, a washing machine is a household appliance used to wash clothes. Second, the electrical energy into mechanical energy when the washing machine is used. Third, the average field water temperature is calculated periodically, and while one water valve remains open, the other water valve operates the microprocessor to calculate the percentage of time required to reproduce an actual field water temperature equal to the desired water temperature. For the last, this configuration does not monitor or measure the state of its output signal, as there is no feedback to the essentially manual electrical control system. For the application of the control system washing machine is an open loop system and monitored by the level sensor. Water level control switch inside the body of this switch is a small plunger. There is a block diagram. So for the input is desired level, and for the output is controller. For the feedback is the capacitive sensor. This is our system modeling and transfer function. For the transfer function, we get the equation is 16 per s power of 2 plus 4s plus 8.
Hello, my name is Muhammad Hakimi bin Yusri, and today I want to explain about the calculation of our assignment. For the first question is to convert the system transfer function to state space representation, which is our transfer function is 16 over s square plus 4s plus 8, and we do the calculation and we got the state space representation for s dot 1 and s dot 2 as above. And for the stability of the system, a system is said to be stable because the output is still under control, which is the value of our damping ratio is 0.25, which can be categorized as under the underdamped condition. In this case, both poles are located at complete conjugate on the left-hand plane. So in conclusion, we can conclude that the system is in a stable state. So the last question is to the steady state error for step input, ramp input and parabolic input. Our GS is 16 over s square plus 4s plus 8 and rs equal to 1 over s. So we do the limit for s approach 0 for the three of them, and we got the first step input which is 1 over 3, and the ramp input is infinity and the parabolic input is infinity.
Now, I will explain how to calculate the calculation for the system response graph. Firstly, the equation for the system is 16 over s power of 2 plus 4s plus 8. Then we calculate the natural frequency, which is omega n power of 2 equal to 8. Then the omega n is equal to 4. After that, we find the damping ratio, which is 2 zeta omega n equal to 8. And then after that, we calculate the value of damping ratio, or zeta, is equal to 0.25. Next, we calculate the peak time, which is by using the formula pi over omega n set of 1 minus zeta power of 2, and the value of peak time is 1.04719 seconds. Next, we also calculate the percent overshoot, and we use the formula e power of minus zeta times pi over set of 1 minus zeta power of 2 and multiply with 100, then percentage overshoot is equal to 4.319. Meanwhile, for the setting times, we use the formula 4 over zeta times omega n, and the value is 4 seconds. For the rise time, we use the formula 1.76 zeta power of 3 minus 0.417 zeta power of 2 plus 1.039 zeta plus 1 over omega n. Then we put the value of zeta equal to 0.25 and the final value for the rise time is 0.315 seconds. For the simulation of the graph for the system response, we are using the MATLAB online. Enter the command h equal to tf transfer function and then insert the bracket and then open the square bracket, then input the numerator value which is 16 and then close the bracket, comma, and open again the square bracket and put the denominator value 1, 4, 8, then close the square bracket and also put the semicolon and then enter. Then next type the step plot and don't forget to mention h. Then the graph of the common will appear at the figure 1 area. Next, click the right click and click the characteristic and click the peak response. So here is the peak response and here is the value. Then click the rise time and the rise time point will appear and also the value of the rise time point will appear. And also tick at the settling time and the settling time point will appear, and also do not forget to tick the transient time. After that, go to the command window and we need to put the command which is we need to type the data equal to step info. To recall, with type h and the result will appear. As we can see, here is the result and here is the rise time. Here is the return time, settling mean, settling max, overshoot, undershoot, peak, and also peak time. Here is the result of the data and the graph simulation for the system response based on the command from the MATLAB application. From the data of the peak time, rise time, settling time, and also the percentage overshoot, there are a different value between the value from the graph and also the value from the calculation, which is, we can see that the peak time and also the rise time, the value from the graph is higher than the value from the calculation, and also the settling time, the value from the graph is lower than the value from the calculation.
Okay, my name is Muhammad Ikhwan bin Zahurin. My metric number is B0920102214. I will explain now about discussion. Based on the assignment, washing machine is a household appliance used to wash clothes. This machine is an energy that transfer from electrical energy to mechanical energy. The washing machine use level system to complete the process based on setting that we put on it. Washing machine is a closed loop system. The process have feedback that always looping based on setting that we choose. The machine is use a water level sensor to prevent from overflowing water when the process starts. Okay, now about analysis. For the transfer function, we assume that Gs is 16 over s of the power of 2 plus 4s plus 8. That transfer function is for preferred input. From the transfer function, we have obtained the graph of the step response by operating a simulation using MATLAB software feature. From the graph, we were able to identify the peak time, rise time, settling time, and percentage overshoot. Okay, now lastly about the conclusion. In conclusion, we have learned that the combination of block diagram and transfer function is a powerful way to represent control systems. Transfer functions relating different signals in the system can be derived by pure algebraic manipulations of the transfer functions of the blocks using block diagram. In this assignment, we use a washing machine as a machine cycle to allow us to run the machine at a set time and water level according to the settings that have been made. As this system is a closed loop system, a sensor is used to measure the process variable and provide feedback in the control system. Based on the MATLAB software and manual calculation, this control system of washing machine is considerably stable. Okay, thank you.